Hi, my name is Cami Newmeyer, and the name of my project is Temporal Metrics, Quantifying Human Time Perception. This is a data science project for the course Data Science Practicum 1 at Regis University, October 8th, 2023. My project objective was to introduce an innovative approach to understanding and quantifying human time perception. It's a brand new insight into long-standing question: how do humans perceive the passage of time? It has far-reaching implications for individuals, society as a whole, space exploration, general health and well-being. My novel framework involves the distance equals rate times time paradigm, and in this case, I postulate that this formula can be metaphorically applied to human time perception, where distance doesn't signify a physical journey, but represents the cognitive journey our brains undertake in a 24-hour span as they process a myriad of stimuli and experiences. Building a data set and applying machine learning, question, research, build the data set, explore the data, train a model, evaluate the model. Interestingly enough, I've been studying this idea for 10 years, and it was only recently that I was able to, with the advent of ChatGPT 4.0, to really research all the questions that I had in a singular location. So that's sped things up quite a bit. So the data set has a lot of features that are engineered, and this comes through mathematical formulas and the applications of frequency, wavelength, those types of things. And the model that I chose to use was the random forest classification model. I have multi-class target variable. Why are we even talking about human time perception? It's a unique experience. It can't be quantified. That's also what Dr. Arthur Skip-Lupio was told about when he quantified how humans communicate. His application was he applied game theory to human communication. And ultimately, that resulted in Juan Manuel Santos from Colombia receiving the Nobel Peace Prize in 2016 based off of his work. An interesting quote that I'd like to focus on is time is basically an illusion created by the mind to aid in our sense of temporal presence in the vast ocean of space. Without the neurons to create a virtual perception of the past and the future based on all our experiences, there's no actual existence. And the interesting part about this is the reference to neurons, which was my approach. Developing a question, time perception varies by age, activity, is altered by physical conditions, mental conditions, pharmaceuticals. It varies by person. It varies by culture. And interestingly enough, individuals can alter their own perception of time. I wanted to connect Einstein's theory of special relativity, where he states that time is relative to your location in space, and also include Weber's theory, which is an interesting theory that I discovered. It was developed in the early 1800s, talking about a just noticeable difference, which is what time perception actually is between from one human to another. And also brainwave frequencies and altered time perception. Our brains have been studied extensively using EEGs, and brainwaves have been mapped, and a lot of research has been completed where certain cognitive disorders or mental disorders, all sorts of things that can alter the perception of time, and what brainwave state those particular conditions are associated with. So what I've taken time, a special relativity, the distance equals rate times time formula, the applications of neurons, and that sort of quantum level of thinking to develop this model. A potential formula might look like delta t, where delta t is the altered perception of time, k is the constant derived from Weber's theory, which I included in my data set after I derived this. Distance is the theoretical distance traveled by the brainwave, and I actually applied calculations to this value. Okay, the first thing I want to talk about are brainwaves. Each of these is assigned a frequency based on research, um, neuroscience research. The first one is the delta wave. It has a lower frequency. It's associated with deep sleep, infant wakefulness, certain brain disorders or injuries. Theta is also light sleep. Alpha, low beta, mid beta, and high beta are generally where adults spend most of their time, are in those brainwave patterns. Mid beta is focused cognitive processing, alertness, and vigilance. Gamma can be associated with higher cognitive processing. It generally happens in bursts, but it's also associated, interestingly enough, with things like epilepsy, migraine, schizophrenia, and overstimulation. So myelination is an important factor in this study because certain disorders decrease myelination. For example, MS has an associated 40% decrease in myelination, which slows down the speed at which these neural patterns travel through the brain. My methodology included researching data, all sorts of different areas. I used ChatGPT-4. I was able to rapid fire a lot of questions. There's access to comprehensive data. The interactions were efficient, and there's a dynamic learning approach. So although my research topic is original and brand new, I was able to access a lot of learning in a really short period of time. My data analysis involves brainwave activity and associated tasks. Alterations in human time perception is the Weber constant K that I developed, and also the research involved in which types of conditions show an alteration in time perception. This next slide shows my feature design, the description of the feature, and then the shortened version that I used in my code. So I completed wavelengths, cycles, calculations for distance, time, and then at the very end, I was able to come up with a Weber's constant that I was going to apply to each of the different types of conditions and how they perceive time, if they're perceiving it quicker or slower. I chose random forest models because they can really address the complexities of multi-class classification problems. And there's also an interesting visualization component if you're using a decision tree model that I looked at. And so the first thing I did was develop a subset. And because these things are related by mathematical formulas, I just took the distance traveled during an average day at each brainwave level. You can see down here the total distance, total rate, and the Weber constant are all correlated really strongly, and that's because, of course, mathematically they were all used to derive the next version. The Weber constant distribution shows us that there is, in my data set, the conditions that I looked at, there is a shift to where time is being perceived slower more often than it was being perceived as moving quicker. So something that might be perceived as moving slower would be like depression, or a condition like anxiety, you would perceive it as moving faster. So some of the conditions that I analyzed are listed here on this slide. I also included different types of meditation, different types of drugs, legal and illegal, different types of cognitive disorders, learning disabilities, mental health disabilities, and physical disabilities as well. And the target set in my data was this altered perception of time. Are you perceiving it moving normally, a condition that can go both ways, faster or slower, like PTSD, a condition that perceives time as moving faster, or a condition that perceives time as moving slower. So in my models, I ran several different versions and I looked at the accuracy and which features were most important. Um, in my subset, that's this first 7 sets of models. The accuracy wasn't really that great, but then I moved to the full data set that included everything. And I was able to do some parameter alterations and get that random forest model up to 75%. The interesting thing about this model accuracy is that you can see that the distance spent, the distance traveled in mid beta waves is the feature that contributed the most to the perception of time, which I found to be an interesting outcome. The very first thing I did was I ran a decision tree model. I just wanted to see how these were connecting and what the logic was, what the splits were, and that sort of thing. Of course, the accuracy wasn't that great, but I really appreciate the visualization. The most accurate model that I used was a random forest classifier, and I did a lot of parameter tweaking and trying to get things to where I could get that accuracy level increased. I found that tenfold generally worked best on the grid search. And so my number of estimators was important, the maximum depth, the minimum samples for the split, and at the leaf, and then the maximum numbers of features. So I changed these parameters several times and was able to come up with this last successful accuracy model. The next step, part 2 of this study, is going to be where I develop a representative set of the population, the adult population in the US over the age of 18. And my intention is to use 0.1% of the population and match it with percents of the known US adult population that has varying conditions that are listed in my original data set, and design features and engineer features and include those that will really give me some deep understanding. The next model I intend to use is a deep learning model, neural networks, in order to go in and hopefully discover some more interesting relationships to how humans perceive time. This study is personal to me. I remember being a young child when I was doing something and playing. It was great fun, and time seemed to go by really fast. But then when I was in trouble and standing in a corner, time seemed to go by really slowly. So this project actually came to mind when I was in kindergarten. And so like I said, I've spent the last 10 years trying to find a way to quantify this. And with the improvements that we've had in machine learning and the developments in artificial intelligence, I was finally able to come up with a method to quantify how humans perceive time. And the thing I want to leave you with is this song by Chicago Transit Authority, released in 1970, but generally attributed to 1969. And I don't want to age myself, but I would say that was an important year. And so I'm going to play you out with does anybody really know what time it is?